Hello everyone, my name is Ravi Badoria and this is my project AIML based SSH brute force detection using Honeypot and Sandbox system. Inside this project I built a small security system that protects SSH from brute force attack. I used a simple ML model to look at user behavior. If the user behavior looks normal, the user goes to Honeypot. If it is looks suspicious, the user silently redirected to a sandbox. This keeps the system safe and the attacker never knows. SSH is used for normal login, but because it is open on the internet, attacker try thousands of password. Old tool like fail to ban use fixed rule, but attacker can bypass them by changing IPs or slowing down attempt. So in my project, I used machine learning to detect behavior instead of using only fixed rules. SSH encryption is strong, but the login system allows unlimited password attempt. Attacker use automated tools, bots, and leaked credential to attack SSH. A honeypot looks like a real server to attackers. A sandbox is an isolated system used to trap attackers safely. Machine learning learns the difference between normal user behavior and brute force attacker behavior. My review of 20 research papers showed Honeypot collect brute force attack data but cannot isolate attackers. Sandbox can isolate attacker but are not combined with SSH login. ML is better than rule-based detection for modern attack. But no existing work combines ML Honeypot plus Sandbox for SSH. My project fills this gap. The problem is simple. Normal user makes small mistake. Attackers behave differently. Old rule-based system cannot identify slow or distributed brute force attacks. So my research question is: Can a small ML model detect attacker behavior early and redirect the attacker to a sandbox without disturbing normal user? My objective were build a safe test setup using a three virtual machine, use ML inside the SSH login process, detect attackers early based on behavior, redirected suspicious user to sandbox automatically, allow normal user to log in without confusion, test everything in a real SSH environment. My system has three machines. Controller runs ML and makes decision. Honeypot is fake server for normal interaction. Sandbox is isolated machine for suspicious user. All SSS requests first go to controller. ML checks behavior and sends the user to Honeypot or Sandbox. This architecture is simple to understand and easy to test because each VM has one job: detection, deception, and isolation, and separated. All testing is done inside a small virtual network, so nothing harms the real machine. This setup makes troubleshooting easy and shows clearly how behavior based decisions work. My research method followed simple steps. First, I studied how brute force attack work. Then I studied honeypot and how they capture behavior. After that, I learned how to use ML to detect user behavior. I tested different idea to separate attackers from normal user. Finally, I combined everything inside three virtual machine. I built all three VM using VMware. I install SSH on each one. I use Python and scikit-learn to train a simple logistic regression ML model. The controller uses a wrapper script to check behavior and redirect user. The ML model check password. ML only checks ML after that checks behavior as well. I tested two scenarios. Scenario first is normal user. A real user makes one small mistake. ML marks them as normal and sends them to the honeypot. They log in without problem. Scenario 2, attacker multiple fast wrong attempt. ML marks them as suspicious. They are automatically redirected to the sandbox without knowing. The results were clear. Normal user logged in normally. Attackers were redirected quickly to sandbox. ML detected attackers after a few attempts. Honeypot logged all activity. Sandbox safely isolated attackers. The system acted like a smart security gate. This project shows that even a simple ML model can improve SSS security. The three-part architecture worked well. Controller did detection, honeypot collected behavior, sandbox isolated attackers. The system was easy to test and easy to understand. There was some limitation. The ML model was very simple. The data set was small, very slow. Brute force attack may still pass. Honeypot was basic and did not capture deep activity. Testing was only done in a virtual lab. In future, the system can be improved by using more training data, adding more behavior features, making the sandbox more realistic, adding real-time alerts, using advanced ML models, building a monitoring dashboard. In conclusion, this project shows that ML, Honeypot, and Sandbox can work together to protect SSH from brute force attack. Even a lightweight ML model can make a smart decision early. Now I will explain the first code file in my project. This file is called infer target.py and it is stored on the controller machine. This is the machine learning decision file. Its job is very simple and small. It takes the number of wrong password attempt, checks the ML model, then decides whether the user should go to Honeypot or to the sandbox. The code reads the how many wrong password attempts user made. It loads the ML model file called controller classifier.joblib. The ML model looks at the number of failed attempts. If the model thinks the user is normal, it will redirect you to Honeypot. If the model thinks the user looks like an attacker, it will redirect you to the sandbox. So second file is called sshml wrapper.sh and it is also on controller. This is the main script that control the whole behavior of the system. This script is the bridge between SSH and machine learning. When a user tries to SSH into the honeypot, this script is activated. First, it checks how many times the user already typed the wrong password. This number is stored in a small file called AI fail count. Then the script try to log in into the honeypot with password mode. If the login succeed, the fail count reset and the user enters the honeypot normally. If login fails, the fail counter increases by 1. Then the script asks the ML model what to do next. The ML model from the first file says either honeypot or sandbox. If a ML says sandbox, the script immediately sends the user to the sandbox machine without asking the password again. If ML says honeypot, then the script simply exit and allows the user to try again. So basically, this script control SSH login. It collects behavior, it talks to the ML model, it redirects the user based on ML output. So together, these two scripts makes the whole system work like an intelligent security gate. So how they work together? User tries first SSH, the wrapper script count how many wrong attempt happened. It sends this number to the ML decision script. Then ML script replies with the honeypot or sandbox. The wrapper script redirects the user silently based on the answer. So effectively, the ML script make the decision and the wrapper script perform the action. This is how the system will demonstrate my practical part. So this is my controller machine. First, I will show what is my IP of all of the three VM. See, you can check that my controller machine's IP is 192.168.56.12. And now I will check what is my sandbox IP. You can check that my sandbox IP is 192.168.56.11. So this is my sandbox IP. Now I will check what is my honeypot IP. You can check that my honeypot IP is 192.168.56.10. So now I will check that all the machine are talking to each other or not. So I will ping from controller to my honeypot 56.10. I will see that ping is working. Yes, it's talking to my honeypot machine. Now I will check that it's talking to sandbox machine or not. Yes, it's talking to sandbox machine right now. So after that, what I will check now, I will check that how SSH will work and how my controller will work. So first I will try the first scenario as a normal user. So first I will try to log in as a normal user into the Honeypot system. So my Honeypot system IP is 192.168.56.10. You already know that. So the count is 0. So right now I will put the correct password for my Honeypot and I will do the login. Now I will check what is my IP of this system. See, you can check now that normal user is not having any trouble. They are able to connect directly to the Honeypot system. So it is Honeypot system I am having right now. So now I will exit from the system and this is closed now. I will do the clear. Now I will work as a brute force. Now I will try to explain the attacker scenario. So right now I'm an attacker and I am trying to log in into Honeypot system from controller. So this is I don't know the password, but I'm just guessing the password. I'm doing the brute force attack right now. I'm putting the wrong password. See, it failed. Now I'm trying again. I'm putting again wrong password. See, See, without asking me the correct password, it redirected to me my Sandbox system, and this is and you already know the my Sandbox IP was 192.168 and 56.11. So this is how like my ML model works. It detects the behavior, it count the attempt that how many wrong attempt has been done. So this is my pros